question, we've already acknowledged that at time t over 2, it's going to be at its maximum height. So now we're just using the same kinematics equation and solving for delta y and plugging in these numbers. We have to recognize that the acceleration due to gravity is a negative number. That means that everything in the right-hand term is going to be negative and be subtracted by the term from the term on the left. So when I do that, I get roughly around 27 or 28 meters is the maximum height. Are there any questions on that part on how we got 28 meters being h max? Okay, the last question, I'm going to kind of push you off in a certain direction. We're being asked to figure out about the velocity at time 1 second. Is the ball still on the way up, or is it on the way down at time 1 second after it was fired? Still on the way up. I don't know where it is, but let's say it's somewhere over here. What can I say about the x component of velocity? Same or different? Paul? Yeah, it's got to be the same. We know the x component of velocity is not accelerated. It's 15.7 meters per second to the right. And it's 15.7 meters per second to the right the entire time the ball is in the air. How about the y component of velocity? Is it still 23.2 meters per second? It's not. Colin, do you think it's a bigger number or a smaller number? Smaller number. If I throw this marker straight up into the air, after I let it go, its velocity starts to decrease until it reaches its maximum height, at which point it's 0, and then it starts to increase in the negative direction. So we could say then that all we have to do is figure out what this velocity is. We don't know what it is. We got to figure out that y component of velocity. Once we know it at time 1 second, once we know it, we're going to add 15.7. We're going to do a vector addition problem. We're going to add 15.7 to whatever this is and find the hypotenuse. The hypotenuse is the magnitude, and we can use some other trigonometric relationships, think SOHCAHTOA, to find the angle theta. So I'm going to give you guys another couple of minutes to see if you can figure out what that unknown y component of velocity is, and once you've figured it out, put those things together using the Pythagorean theorem and the tangent function.